target the SimTwo realistic simulator users that desire to expand their knowledge and simulate the mobile robotics element in a MicroMouse maze. By the end of this tutorial, you should have successfully download and install SimTwo realistic simulator with a MicroMouse package, learn how to generate a maze, learn how to run the MicroMouse application, and also understand the advanced overview behind the robot editor and scenes editor scripts. All the links in this video are going to be in the description below. To start, go to the second link in the description below and download the SimTwo MicroMouse simulator. Hit download, direct download. After the file is downloaded to your computer, right click in the file and extract the file. I'm using a 7-zip. You can use WinRAR, you can use 7-zip or any other software to unzip your files. So I'm gonna extract my files. I'm gonna create a folder in my computer called SimTwo MicroMouse. I hit OK. I'm gonna hit OK, and all my files extracted for that location. So now I'll go back to that location, open my folder, SimTwo MicroMouse simulator, double click again. So the first thing we're gonna do, now we go here and run our SimTwo realistic simulator. Now you can see that the robot is already running this script. Here's our robot in our maze. So if you try to get closer with your mouse wheel, you can get closer and you can see the robot is moving. So let's minimize for now and go here and stop for the moment. You can see the values over here. We're gonna go here and I'll cut code editor and stop. Now if you go back here, you can see that our robot's right there. It is in stop position. Okay, we told them to stop. We went to the code editor and this is our robot. You can see different shapes, the left wheel, right wheel, axles, and all the elements that compose our robot and also our maze. So we're gonna minimize this for now. So to bring our robot to initial position again, we're gonna go in Scene and hit Rebuild, Ctrl B. Now this put our robot back to the home position at the 0 position right here. So you can see that our robot now is not moving and is in a home position. So you have a left sensor, a frontal sensor, and a right sensor. So that's the way the robot detects the walls of the obstacles and decide which route to take based in your code. And remember, this is our home position right here. We have two vectors, the X, Y over here, and we have 3 bings, left bing, front bing, and right bing. That's the sensors, that ultrasonic sensors that gonna detect our wall. Remember, this is realistic simulation we're doing right now, and we're trying to determine how to go from one side of the maze to the other side of the maze and get out of the maze. That's the purpose of this exercise. To control the maze itself, we have the XML scene editor that are gonna give you 3 different tabs. Tab number 1 is the Scene tab, Robot tab, and Obstacle tab. The Scene tab basically controls our main scene that you see here, the background for the scene itself and the elements on top of that scene. So you can see that we have the robot XML file, parts of the scene, and also the obstacles part of the scene. And the scene XML determine to us our position, initial position for our robot. Where's the robot gonna start? Right here, determined by our scene.xml. The next step is robot XML. The robot XML is used to determine the shape of the robots, the dimensions of the robots, the physics of the robot, the mass of robots, the PID loop. If you grab here, so let's do some exercise. So you can look the robot and see the parts of this robot here that you are controlled by the default script. So, oops, it could be a little challenge to move this. So it's a lot of fun. So you can go back here, go back to your scene XML editor and rebuild that robot, go back to the 0 position. It's amazing. So it's right there. And so remember, the robot XML has several parts in it. And there is 5 main elements that define a robot. The robot is defined basically by the shapes, the dimensions, the shells, the sensor, the joints, and the articulations. That's the robot itself. Now remember that when we consider the scene itself, the main 2 things we can see in a scene over here are the robots and the obstacles. Those are the 2 elements that belong to a scene. Now the robot itself has all those 5 elements. Again, shape, dimension, the shells, the sensors, the joints, and articulations. So you can see your code, this default script for the robot, starting here with the robot dimensions. These are the first part of our XML. You can see the robot width, the length, the thickness, the height, the mass, and you can go here and change from the default value. Also the distance to wheel to center, and all the information about the motor constants, the mass of the motor, the wheel constants, the mass of the wheel, the cast constants, the calculate measures. So the first part of the code here defines the dimensions of your robot. The second part of the code I'm gonna show you is the solids, the parts that gonna make up your robot. So your robot is made of parts. So the first part you can see here is the plate. Then the second one is the left wheel. The other one is the right wheel. And it has information about the mass, the diameter, the position. So here are the shape of the robot. You can change the cylinders, all the information that embedded in this code, part of the code over here. So here are the robot shapes. So remember, the first part of the code we saw are the robot's dimensions. These are the dimensions of the robot right here. The second one are the shape that start here with the solids and go all to the way here. The third part of the robot XML file are the shells. Now your left bracket, right bracket, left motor, right motor, everything by default is defined here. But you can go ahead and change to your own application. If you want a different shape of robots with a different shell, you can come and change this part of the code. After this, we saw already the dimensions, the shape, the shells of the robot, and the third one is articulations, joints and articulations, the fourth one. So first one, dimensions, second, shapes, third one, shells, fourth one, articulations. And articulations, now the right motor, right here. You can have now information about the right axis, the left axis. You can have the gearbox, and also you can have the control loop here the PID for that part of the code. You also have an encoder that you're gonna simulate that the right motor has an encoder that has 400 pulse per revolution, PPR, right here. And also the friction, the viscous friction, and all the elements for your calculations is right here. So you can change that. And also, even the standard deviation, you can enter here with a mean for all information regarding to the first one robot, the right motor right here from your robot. And now you're gonna have now your joints. So you have a left axis, and here are the parameters for your left axis. Then again, the right axis right here, another joint. So joints and articulations is the fourth part of your code. The last part of the robot XML file are the sensors. They are infrared sensors. They have three sensors: left, front, and right sensors, like we saw over here. Infrared left, front, and right. And here are the values from the script. You can change that according to your needs, according to what kind of precision you want for the beam length, for the initial width, and so on. So that can be changed from the default to suit your application. The last tab you're gonna see the XML scene editor is the obstacle XML. So basically the XML, they're cuboids, and those cuboids, they are not movable, they're fixed, because they are the walls of your maze. This is the XML that we control our maze right here. Based on the complexity that we can create more complex, simple, we can add walls, we can delete walls based on our XML code for the obstacles. And you can see that we have size, position, rotation degree, and a color. You can see they are red. For example, I can change this red here, put a 0 here, and put a green here, 128, and go here, and then I can go scene and rebuild. And then you're gonna see that I just changed this wall right here. I changed from red to green. You see now? So you can change the color from your maze based on obstacles, right? And so let me go back here. I'm gonna go back here and change this to 128 and put this 0. So you know that this cuboids here is that big wall in the bottom. So I'm gonna go back here and rebuild, and now you're gonna see that red again. Okay, so you can change the colors, you can change the shape of your maze, change the values for cuboids in your obstacle.xml file. So continue our tutorial here. We already saw the XML scene editor, where we have the 3 tabs for this particular application, the MicroMouse maze application. And one thing here is important to pay attention to this particular page here. Similar to Excel, here we have the frontal sensor, the right sensor, and the left sensor. These are measurements by the infrared sensors that we're gonna simulate. So if you go here and rebuild your sensor, the maze, our robot is right here at the home position. And now we're gonna go ahead and go in our code editor and program, and we're gonna run our script. Now you can see that your robot is running, highlighted there. And here you can see the values that we are simulating. And we're gonna minimize this. So the robot is moving in the maze, and we can see the infrared values for front, right, and left, and also how long the right wheel has, the distance has traversed, and also the left wheel. So here's the left wheel, here's the right wheel, and here's the values, that different values for different wheels we're simulating based on our script. So you can see the robot is following the script, the original script that we saw for the definition of the scene itself, for the walls, for the dimensions, for the shape and color. But the code itself that controlling how the robot is moving, it's our code editor based over here. So if you look in our code editor, these are Pascal code that define the control of a robot inside the maze. What kind of decision? So we have here if statements. If the front sensor it's less than 0, then we set a value 5, for example. If it's right sensor is less than 0, we start as a 5. If left sensor is less than 0, we start as a 5. So that's our initial values right here. So we get values from the sensors. We start values itself. We're setting minimum values for the sensors. Remember, you're trying to emulate a true robot. You're simulating a true robot, right? Pay attention to this notes here at the top, the comments. Okay, and that's very important to know where you're going to store the position. If there is a fault, and there is position that you can keep track of this. And here's your code where you can define the decision making of your the PID loop you're going to be controlling your robots based at your XML start definitions, the PID that you gave in XML. And here is also going to be the definitions, the measurement itself, how you're going to turn it, what decision you're going to, if you're going to go left or right. It's all in your code right here. It's all in this Pascal code that's going to help you make the decision how to get out of the maze. And right now, our robot is still looking for exit. He's right there. So I highlighted the robot, so that's the reason you can see this color. Now, see, I'm gonna click on the robot again. So the infrared sensors, left, right, and front sensors, is trying to find an exit. And from here, to the other end of the maze itself. So basically, these are the most important parts. We also have the pages for the configuration itself. When you launch the MicroMouse, if you have a dark screen, so here we can go in the tabs first. But it's important that if you notice a dark screen when you launch your application, important that you go in the configuration tab. To reach in the configuration tab, you can just go here, go in your main scene, right click, and go to your configuration. Then right here, go in this second tab, you can see tabs. Those tabs here, control, graphics, debug, physics, IO. Go into graphics, and you're gonna change your camera position, move with robot, right here. You can see the difference looking at the robot. I can see a fixed position, but I can say move with robot. I can do above robot or top view, but I'm gonna do move with robot. And now the camera is gonna move according to the robot is gonna be moving. So when you launch application, if you have a dark screen, that's the way to do it, to fix it. So you go in a right click in main screen, go in config, go in graphics, and select move with robot. So I hope you enjoy, and if you have any questions, please don't hesitate to send us an email.